So today we're going to tackle problem 12.82, and it actually is one of the problems that are comprehensive, but as I'll show you, it's not as hard as it seems. So when you look at this problem, you think, there's a lot of things in this problem, and how do I fish out what I need? So what you want to do in like every problem is you want to write out what you know. So what they give you is that your T1, or your initial temperature, is 20 degrees Celsius. They also tell you that the pressure for mercury vapor at this temperature is 1.20 multiplied by 10 to negative third torr. And as you keep on reading along, they tell you more information that the heat of vaporization for mercury is 59.1 kilojoules per mole. And then at the end, they want you to find the temperature of the vapor pressure of mercury at 5 point, so then your P2 would be 5.0 multiplied by 10 to negative fifth torr. And they want you to find your T2 for this. So your T2 is the question, is what you want to find at the end of this problem. So when you think about this, they really don't tell you what equation to use, but the only equation you can really use is Clausius-Clapeyron equation, because they essentially give you all the variables for it except one, which is your T2. And what I do is there's a hint. Usually when they give you like heat of vaporization and like pressure and temperature, it usually goes to that equation. So we're going to write that equation out right now. So it's ln of P2 over P1 equals the negative value of the heat of vaporization divided by an R value multiplied by the inverse of T2 minus the inverse of T1. All right, so now that we look at this equation, we can see that we actually have essentially all these units. But before we put these units in, let's look at what we have to convert. So we know that the temperature here is something we have to convert over because it's in Celsius, and we always work in Kelvin. So we're going to convert that right now, and that equals 293 Kelvin. All right, so that's all the conversions we actually need for this problem. Oh, and we also need to convert this to joules, and you'll see later why when we look at the R value. So it's going to be 59.1 multiplied by 10 to the third joules per mole. And you'll see why I converted it over. And a good standard to know when you work with this equation is that you should always convert everything to joules because your R value will be in joules. So now we're just going to plug in values. So it's going to be the ln of your P2 value, which is 5.0 multiplied by 10 to the negative fifth torr, divided by 1.20 multiplied by 10 to the negative third torr, equals the negative H vaporization value, which is 59.1 multiplied by 10 to the third joules per mole, divided by the R value, that is 8.314 joules per Kelvin mole. And you don't use the other R value, which is 0.0821, because that doesn't have the units you need, which is joules. So you have to use, so for this equation, you always use the value of R, which is 8.314. And now you just plug in your temperature values. You don't know your T2, so you're going to leave that as a variable. And now you're going to put in your T1 value, which would be 293 Kelvin. So now all it is just math. So I'm going to just write out the math steps for you. You want to simplify this, so you get negative 3.17805 equals, you simplify this, negative 7,108.49 multiplied by this value. You really can't simplify this yet, so you keep it as it is. 1 over T2 minus 1 over 293 Kelvin. So now we want to divide each side by negative 7,108.49 because you want to isolate the T2 eventually, so you're going to divide this first. So what you're going to do is divide each side by that. And now what I'm going to do here is I'm going to erase, I'm going to move over here so you can see it out. So now the value you get for that is 4.47048 multiplied by 10 to the negative fourth equals 1 over T2 minus 1 over 293 Kelvin. So what you're going to want to do now is you want to still isolate for T2, right? So you're going to add this value to each side. So what it's going to be eventually is 4.47048 multiplied by 10 to the negative fourth plus 1 over 293 Kelvin equals 1 over T2. So now all you have to do is add them together, and you get a value that is, when you add them together and then you flip it because you want the inverse of it, you get T2 equals 259.064 Kelvin, which equals approximately 259 Kelvin. And you may be wondering how I get the units from here to here. Well, when you start canceling out, remember always look at your units, and in my head I kept them in my head, but if you can't keep them in your head, make sure you cancel them out, and you can see that there will be a Kelvin here, so then it will be essentially K negative up here. So that's how you eventually get the Kelvin on the top. So make sure you also look at your units when you do this problem. That's how you do the problem.